Hi, and welcome this afternoon to Java at 25, our retrospective and futures talks. My name is Ken Rimple. I work for Chariot Solutions, and I'm here with Tracey Welson-Rossman and Aaron Mulder. And we will be having Brian Getz from Oracle join us in about an hour, actually 45 minutes. So let's get started in basic introductions. And 1 second before we do that, I need to turn on something. That helps. All my notes. There we go. All right. So we're going to start off the talk today. We're going to have two sessions. We're going to start in a minute or two with Drinking the Coffee, Chariot's multi-decade journey with Java. That'll be Chariot's CMO, Tracey Welson-Rossman, who will be interviewing Aaron Mulder, our CTO, and will also be participating as another person in the interview. And that'll go from right now until about 4 p.m. Just before that, we'll take a quick break and set up for the next one, which is Java Futures. It'll be on the same Zoom chat, so just stay on. And we're going to bring on Oracle's Java architect, Brian Getz. He's a good friend of Chariot and of Philly Emerging Technologies for the Enterprise, and has spoken here for 3 different events. And he's going to join us for where Java is headed for the next 25 years. That's a tall order, right? But we'll at least see where it's headed. Today at 5 p.m., we also have a happy hour. We're going to use a tool called Gather. It's a web-based chat and discussion tool where you can kind of walk around in a virtual environment and talk to other people to meet up and chat with each other. We're going to provide some links in the chat. They have been sent you an email as well. And you'll see there are 2 chat rooms. There's one if you want to talk about Philly Jug issues and interests, and another one for just general chat. Visit one or both and feel free to flip between them. So please join us for that as well. If you have questions for the speakers today, just use the Q&A panel in Zoom to ask your questions. We'll answer them at the end of each session. And also feel free to chat with us in the happy hour. We'd love to talk to you. And this is brought to you by Chariot Solutions. And we're very happy to bring this kind of event to you. If you want information about us as a company or consulting firm, you can visit our website at chariotsolutions.com. But we very much are involved in doing a lot of Java development over the years, which is why we're hosting this event. Also, thanks to the Philly Jug. It's been active for well over 15 years and has events happening frequently. Visit them at meetup.com/PhillyJug, and we thank them for helping us get the word out on this event. Also, Zip Code Wilmington, a nonprofit software development boot camp in Wilmington, Delaware, that's strongly career-focused and covers Java-based application development as well as other technologies. And you can visit them at zipcodewilmington.com. And I'm going to bring on our panel. So with that, Tracy, take it away.
Well, thanks for joining us, everyone. As Ken said, I'm Tracey Welson-Rossman. I'm Chief Marketing Officer at Chariot Solutions, and I'm one of the early founders at Chariot. And, we started, we just crossed the 18-year-old threshold in July. And our life began focused on helping companies make the most of their choices of Java for their software development platform. There were 5 primary goals in the creation of Java from its founders, including James Gosling. 1, that it must be simple, object-oriented, and familiar. It must be robust and secure. It must be architectural neutral and portable. It must execute with high performance. It must be interpreted, threaded, and dynamic. The landscape of tools and technology choices has changed over the past 18 years of Chariot's existence, but Java has not gone away, even though there's been many rumors of its death. So I'm joined here by Aaron Mulder, who's our CTO and another early founder, and thanks to Ken for kicking us off, and he is our Director of Mentoring and Training. And we're just going to have a discussion about our relationship with Java over the years, and also how it relates to the other languages. So we're going to start off pretty simply asking both of you, how did you get started with Java? And we'll start off with Aaron.
Was that not on the do not ask list? Because I'm afraid I got started by writing an applet It was an applet
That
to put a lot of colorful stuff on your screen and some animation. It was like a blink tag on steroids. So yeah, that was how I got started with Java. I moved on, I assure you.
And Ken,
Yes.
Are there dirty secrets in your closet around Java?
Nothing I will disclose. I started off similar to Aaron. I was actually working in client server technologies, and at the time a tool called Power Builder. And I was a database geek, so I was into SQL Server and Sybase and Oracle and things like that. So I usually worked on the database side of projects. And I really, Java clicked with me, and we, as a company, the company I worked for at the time, were doing a lot of training. That was one of the things I did a lot. And I think I was one of the first Java trainers in the Philadelphia area. I went and got certified by Sun, and then wrote chapters, because the training didn't really have, it was really user interface driven, building applets. So they didn't have anything on the database stuff. So I did a JBC chapter, I did an RMI chapter, and a networking chapter. And then eventually I went out to do consulting in Java, because I really wanted to do that instead of client server. So that's how I got started back in 97, I think.
You were just a young lad.
Mm-hmm.
So, Aaron, why don't we tell the audience, not everybody may know, how Chariot decided that we were starting with Java for our first project, and what are some of the technologies that were out there at the time that were considered?
Well, I don't think Ken's experience was that unusual. I mean, I had done some work in Power Builder. We worked on a accounting application that had been done in a 4GL, similar. We didn't really want to get locked into one of those tools and be kind of at the mercy of that vendor and their updates and their DLLs and things. I mean, everyone kind of has war stories from using those kind of tools. And we were keen on web applications. So at the time, if you wanted to move to the web, it was kind of Java and JSPs, or Microsoft and ASPs. And as I said, we wanted the more open choice. We didn't want to feel like we were going to be locked in either to a software vendor or to a hardware platform, or limit our clients to only those who were running Windows or whatever. So, Java made sense for a lot of reasons, though at the time there were a lot of challenges too. There wasn't kind of the rich ecosystem there is today.
But I think that was also one of the things that we saw, that companies were struggling with the choices that needed to be made within Java. So that was sort of the business opportunity that we saw.
And you had to make your list of the things you didn't know. You needed something to talk to a database. You needed something to organize business logic. You needed something for a user interface. Like, it went on and on and on. There wasn't like, the out of the box kind of experience of a Spring Boot or something like that. It was, I don't want to say before those tools were created, but a lot of the things we take for granted today at best were kind of in an early release alpha beta kind of form, without the kind of community there is now. And we weren't necessarily aware of them, or our customers wouldn't necessarily have been willing to adopt them in the state they were in. But that was part of what you grappled with. How are you going to do these things, and what tools are there, and are you willing to put your faith in one of them, or do you build something yourself? And it was just so different, 18 years ago compared to what it is today.
Yeah, it is. It really is a marvel to think about. I mean, 18 years seems like a lot of time, 25 years seems like a long time, but it really isn't, with what's been going on. Ken, let me just throw this over to you. What are some of the other features of Java that you think made it a good choice for Chariot?
Well, I think one of the things is it was, being, as Aaron said, not a particularly locked down platform. Everything was embracing of open source and kind of, different development tools. Early on in Java's world, the development tools were kind of horrible. A lot of people were using things like Visual Cafe and Borland, and just desktops were too slow to really do much. But I think by the time we got involved at Chariot, tooling got better. The large open source community that built around it, like you look at Apache, I think without Apache Software Foundation and the Jakarta project, I think Java would have been a lot less of a productivity boost than it was. You know, there were all sorts of frameworks that came about that we took advantage of over time, and as Java evolved, we kind of grew up with it. You know, it's just it's a language.
I did swear by JBuilder for many years. So
Did you?
there was a long time where there were commercial tools that you would have had to pry out of my cold dead hands. I mean, you know, the open source was a big advantage for sure, but
yeah,
you know,
from
it was
the libraries.
a while before.
That's true. Like the libraries were open source, but the tooling was originally rather, you know, proprietary and pay for it or do things.
It was $1,000,
you know,
right?
Yeah,
The JBuilder version that could talk to a database and whatever.
So yeah. Aaron,
if it was pro or enterprise or what. But.
Yeah, true.
You know, you were pretty early on, or very, very involved early in the creation of Chariot with the Apache Foundation and what was going on in open source. How do you feel like that really helped with the adoption of Java?
Well, one of the things people struggled with is learning these new technologies on their own, right? If you had to pay $1,000 for an IDE, you had to buy a database. I mean, there was a time when you couldn't just fire up MySQL or Postgres. You had to buy a book to learn about something. I mean, it was not necessarily a straightforward proposition to get up to speed on the tools you needed to write a real business application. But you know, Java took a big step forward in terms of putting out the Java doc, which was amazingly comprehensive, and the Java tutorial with which you could, you know, get yourself up to speed. And then there was a huge community out there of people willing to answer questions. You know, it wasn't Stack Overflow, it was whatever the predecessor's predecessor was to Stack Overflow. But there were a lot of people out there asking and answering. And then you start throwing in open source software, and you know, you didn't have to buy an application server, you didn't have to buy you know, a database, and you know, you could get an editor or a lightweight IDE that you know, let you start developing software in a reasonable way. And suddenly you could just have a hobby project and, you know, build some stuff for fun and figure out how all these things worked and how it all fit together. And you know, some of those obstacles started falling.
And I know, you know, besides the advancements that were made to Java through the community, let's talk about the community itself. I know this is one of the prep questions that we talk about, but I always find it fascinating that the open source community was so, you know, willing to take chances and just really let people do what they needed to do to you know, get what they needed without having restrictions.
I mean, ultimately, a lot of people who are contributing to those were kind of scratching their own itch, right? They had some problem. You know, I got started contributing to the JBoss application server, working on database connection pools, because it was driving me crazy that, you know, there wasn't a good way to, you know, just fire something up and talk to a database. And other people had other itches. You know, they wanted to have a better way to write a web application besides just, you know, throwing a bunch of JSPs out there or building everything in servlet. So then, you know, there was struts, you know, early on in those days. And, you know, we all wanted to be able to do our thing, whatever that thing was. And, you know, in order to be able to do that, we needed X, Y, and Z. And so we worked on it and put it together. And there was no reason not to let other people help and let other people use it for their hobby projects or to help get them up to speed or whatever. And so, you know, I think there were a lot of people who just kind of looked at this stuff and said, I would love to learn this. I would love to run, you know, a real Java application, but I can't afford WebSphere or WebLogic. You know, I need something I can do, you know, for free. And even if your company was never going to deploy an application except on WebSphere, the fact that you could fire up JBoss on your machine and take it for a spin and kick the tires and, use it for a hobby project, and then you knew how to write, a J2EE at the time application. And, then you could, because of the formal corporate Java community process, these things were standardized, and you could write an application for JBoss and more or less run it on WebLogic or WebSphere. There was a decent amount of configuration tweaking and whatever, but it wasn't like you had to rewrite the thing. And I think that community, brought a lot of power to Java, and eventually started bringing things like Spring and Hibernate that made every application 5 times easier.
Right, and I also think that in a way, it democratized how people were able to use software and build it on their own without being locked in. So, it is revolutionary, at least in my opinion, coming from the business side.
And parts of it were not directly related to Java. I mean, having MySQL or Postgres was a huge advantage over having to buy a database product. And there was no Java in MySQL, but the fact that it was there, and it had a JDBC driver, and there was JavaDoc for that JDBC driver, and there was a tutorial trail for talking to a database, and you could just put this stuff together and get up to speed on it and go.
One thing I wanted to jump in on that too is the other huge innovation for them was getting the public, like starting with Apache and then, Maven, the build tools and the repositories early on, and having some pretty good established processes, given that Java was backward compatible. And that was really key. Having the fact that we could keep versions of libraries that were created and upgraded over time and go back to the historical earlier versions of those made it easier for us not to necessarily break builds and copy files. I remember before that, we used to copy jar files into version control because we didn't have repositories early on, and we thought this is horrible. But all of a sudden, Ant and then Maven came along, and the Maven Central repo and other repos, and that was a huge innovation there. And that really just made it much easier to share software.
Well, let's back up and even talk about jar files. I mean,
oh yeah,
before Java, right? You would have had to compile your libraries separately for different systems, and I've struggled with that in other languages and other environments where I thought I had configured my app for a particular set of dependencies, but there is different stuff installed on the system that the app was supposed to run on than, compared to my development machine. And it wasn't necessarily even different dot release versions. It was just they had been compiled differently with different options and whatever. Whereas in Java, you took a jar file and it was the jar file. If you put that same jar file on your production machine, that's what you got. You put that in the class path, end of story. It was like definitive. Yeah. Like there was no way for your system to screw you up. Like you could just say use A, B, and C, and that's what you got, and it ran like you expected, most of the time. But and that kind of, I guess, comes out of Java's portability. One of those 5 goals, Tracy, that you mentioned early on, the portability turned out to be bigger than we thought. Back in the day, it was like, well, now it can run on a Sunbox or an Intel. It could be Spark or Intel or whatever. But even besides that, just the fact that your libraries were portable and you could get the exact same jar file, no matter what system and operating system you ran on, Windows, Linux, big endian, little endian, like whatever, you got the exact same thing. And that made a big difference. And I think that was probably one of the things that enabled some of open source to spread like it did. That, like you mentioned Maven, and sure, the central repository and the dependency system were huge, but just the fact that, once you put it out there, it ran on all these different systems, just the same, and you didn't need different versions, and you didn't have trouble with things that would or wouldn't run on your box or whatever. The more I've used non-Java systems, the more I appreciate jar files.
That's so true.
Well, I think it's interesting that they set out, the founders of Java set out with a mission and vision and goals of where they wanted it to be. And it sounds like, that gave guidance along the way as they allowed it to happen.
At the same time, I have to say they've gone astray many, many, many times. Like Java server faces and Java
Yeah.
FX and applets and Java Web Start. Many of these things, either they worked well and did their thing for a while, but they never turned out the way I'm sure their creators anticipated. We're not running things in applets today. We're not running our apps through Java Web Start. We're not, we didn't replace Flash with Java FX, So there have been many things that didn't pan out, but so many things that did.
Right.
We're still using bytecode and jar files. We can still, run very old Java applications. It hasn't been perfectly backwards compatible, but it's been pretty darn close. It's never felt like an app needed a major overhaul to move to a new version of Java.
Well, we're going to talk about backwards compatibility. I want to parking lot that because that seems to be a big reason for Java's longevity. But the next step that we saw in the evolution was Spring. So Ken, why don't we start with you and why don't you, tell us your thoughts about Spring and how that helped move things forward.
Sure. So I think that the thing that Spring did was it kind of standardized the way of abstracting out things that you don't want to have to worry about. So, you want to make sure you can always connect to a database or that you've got security on your application, that you can handle, servlets and things like that. If front end, interfaces and network traffic and thread pooling and all the things that you in monitoring. And so Spring came out with a core that said, you put your code in these little simple pieces of software, these little simple objects, follow a couple of basic, standards, and then we'll work all the infrastructure around you and inject it into you. And then over time, Spring, I would say it's about 2005 or so, when then Chariot really started using it, maybe a little earlier than that, all the way through till today. You're running into projects that we do in Spring. Not everything, but there are things that aren't Spring related, and there are different frameworks that are out there that we use for all sorts of other features. But Spring has been kind of a constant in terms of building enterprise software. If you have to hook to a web server, if you have to go back to a database, if you got to, do anything dealing with any kind of infrastructure, it's a good potential solution. And it went through its back and forth. I remember there was a time when Spring Source created this complex DM server, which was a OSGI based Spring server, and they went really down the deep end on that. And most people didn't need it, but they wanted that to be kind of the core of their business. And then ultimately, we were kind of lucky in that VMware purchased them as part of, they needed some sort of software fabric that they wanted to be able to own the rights to, and they kept it going. So, it's been around all these years and it really hasn't strayed much from its original mission. And it's just evolved over time. So grew up with us again.
Interesting to think that the app servers and the Java EE vendors, they had their own community and their own standards. And I guess it wasn't quite good enough. I mean, I participated in those and had my frustrations, but at the end of the day, we did release a standard that people could use, but it was slow moving. It was driven by corporate interests. Everyone wanted to standardize on what they already did to make the least amount of work, right? And meanwhile, Spring was just grassroots and community driven, and it attacked many of the same problems, but in a way that was more driven by the community instead of the vendors. And for a while, you would run Spring in your app server, and today you can run Spring Boot, and there is no app server in that picture. And so you can see how kind of the tide has shifted a little over time.
That's where they grow.
We're still using Java, but we're targeting maybe a different platform.
Right. And of course, I will always hold a little piece of my heart for Spring, since Rod Johnson dropped the F-bomb 3 times at our event. I could ever forget that. I can't. Well, sorry for the little digression. So Aaron, we talked a little bit, you brought up backward compatibility. So I'm going to bring that back into the conversation. And, why do you think that's been so important for the longevity of Java?
Well, you could ask the counter question, why has it caused so much pain for Ruby and for Python and for some of these other languages that have gone through a new major release that brought all these great features but completely broke backward compatibility? But one of the most important things I think is that big companies have adopted Java for important projects and don't want to see them need a complete overhaul or rewrite every few years, right? You want to be able to schedule that when it is urgent for other reasons, not because some language maintainer decided that now was the time to throw out the baby and the bathwater. Sure, you could keep running on Java 8 forever and ever and ever, but you might want to you have people who are writing new code in Java 14 and using new language features and don't want to lose out on that. I mean, I'm sure we'll hear more later on what we're all going to want to take advantage of in the next few years, and you'd like to be able to run that side by side with code that was written a long time ago. You'd like to be able to use open source projects that were released a long time ago. I mean, hopefully they're still actively maintained, but whatever. I mean, sometimes you get into that dependency web where you use the latest Spring and it uses a slightly older logging, which uses a slightly older, Commons utility library or something. And without realizing it, you're using code that's 10 years old and it still runs and it still just works. And it doesn't need a massive overhaul. And it's not that backward compatibility isn't very sexy. I mean, there have been 1,000 times I've said, why is the same deprecated thing been here release after release after release? Can't we just chuck it,
Right.
But, I've got to admit, in retrospect, it was like a genius move, it has really paid off to not have those massive breaking changes.
I remember when we were looking at some apps that were like in Rails 2.3 to 3 or 3 to 3.1, and some of the developers working with those, there were API changes that broke the code, and they would have like a 30-minute presentation on here are all the things that are broken that you have to upgrade if you migrate to the latest version of Rails in Ruby, whatever. So, and that's not the only language like that.
Yeah, how about mobile apps where there's an upgrade every year, whether you like it or not, and you don't even have a choice. Your users are going to adopt it, and either your app is going to break when they do that, or you're going to have to, there's like that forced upgrade cycle.
You're kicked and screamed to it. Yeah, very true.
So, as we were getting ready for this and having our conversation, a point came up about how, some things that you were thinking about, technologies that you thought the audience would be surprised at, that have, new technologies that have Java, reliance on them. So can you talk a little bit about that?
Well, my favorite, Java has gone through a jillion user interface technologies over the years, right? There's been Swing, there's been Auth, there's been Java FX, there's been JSF, there's been all these things. What's the one that is more popular than any other? Minecraft, which is what, using OpenGL binding somehow, I'm sure, it's not even one of the Java graphics APIs. I think it's amazing. It's amazing that you could write a game that popular in Java.
And from a plumbing perspective, yeah, go ahead.
No, I just wanted to know if you had any.
Yeah, I was just thinking, you would think of things like Apache Spark, for example, or I think Zookeeper, a lot of things that power the web, power search engines. There's all sorts of things that are still running in Java today. You might use a really fun language like Python or Scala to query a Spark server, but Spark itself is written in and runs in the JVM, so Java's not going anywhere. It's certainly in a lot of servers out there powered today. And, Android, until recently, it was all Java. Now it's going to be, what is the current language for that? I've gotten a a moment here. What's the
Kotlin.
new language for Kotlin? Yeah. But I mean, you're writing Kotlin on the JVM too, so a lot of things run Java that are very surprising, even, and it's funny, the one place where user interface stuff is still being done in Java that it seems is NASA. They have a ton of apps that control satellites and, simulate rovers and things like that are all written in the Java front end. And most people haven't used Java for front end stuff in a long time, but they do.
Oh, we have a reminder.
Scientific.
We have a reminder from our audience that Flutter is also dependent on Java.
Oh, good. Yeah. There we go.
So thank you. So how do you feel Java's evolved in the past decade to embrace more current trends in development?
I'm sure we're going to hear more about that later, right? But
yeah,
I think part of this shift started with all the languages you can run on the JVM, right? That, Ken mentioned some of these, but, Scala and Clojure and JRuby and whatever, a lot of these languages have brought a new take on syntax, and, some of that's been filtering into Java because people like it.
Definitely the functional stuff is one of the bigger changes that they've made. Is they've gone to kind of functional reactive and operating on things in a functional way, but they haven't changed the language where they're so functionally focused they can't do things the way they could in the past. So unlike a purely functional language, you have both functional and you've got object orientation. In fact, our 2019 ETE, we had one of Brian's talks was about, what was it? It was functional programming or object-oriented programming, choose two. And that was his talk. So it was all about how one kind of informs and helps the other. And that's, when you have a language like Java that's general purpose, adding functionality to it that does functional programming after watching all the other vendors do it, they kind of picked the best way for Java to do that without breaking how Java works. So,
well, and unrelated to the language, unrelated to the language itself, I kind of feel like the development experience is different than it was 10 or 15 years ago, because over time, it just seems like the amount of plumbing that you need to write, it has gone down to the point where today I feel like you're much more focused on, I don't know if I should call it business logic. You're more focused on the code that is relevant to your application and not plumbing and infrastructure. And it used to be you had to open connections to a database, and then you could configure your app server for a database pool. And today, Spring Boot has one, and it's there, and you just use it, and you barely even have to do anything to set it up. And if you're running Java in the cloud, you can run it in a Lambda or something where you don't even have to handle requests coming in or out. You just sort of write your code and your logic, and it seems to be much more focused on in a useful way than it used to be. And that's not down to the language, that's just down to the tools and the environment and the frameworks and the cloud and all these developments over time that have made it so much easier to focus on the stuff you care about and not have to worry about the stuff you don't care as much about.
So we've seen other languages like Ruby and Python generate a lot of interest in the developer community, and yet, Java's still here. Why do you think, we're able to manage multiple languages within the enterprise and other environments?
Well, they do have different specialties to some degree. I mean, I think there's probably a lot more AI code written in Python than in Java, not exclusively, of course, but when you start poking around AWS Lambda, what language, I have the freedom to write anything for the cloud. What do I want to write it in? This language may run faster, may start up faster and use less memory than this other one. So, there are definitely cases for one or the other, but why is Java still here? I think we've covered some of those reasons. It's got this huge support from the open source community, frameworks and tools and libraries. It's got build tools with dependency management that bring you jars that run on any system. It's got the backward compatibility, so you can keep building on the shoulders of giants without them having to rewrite their stuff so you can rewrite your stuff. The Spring keeps getting better and smaller and faster, and you're able to just focus your code on the parts that are of interest, and all these things kind of add up. And a lot of people have Java skill. It's great. The people who love Clojure really love Clojure, but there aren't as many of them as there are people who can write Java, at the end of the day. So, maybe that's a factor for a given application where you are going to need a lot of people on a team, to scale up rapidly. And maybe it's easier to find people. Java still is, very easy to learn. There still is a Java tutorial. I haven't looked at it for a while, I guess, but you can go to Stack Overflow and get any answer you want. You can get good support from the community still after 18 years.
I think it's a genius. Yeah, I'm sorry, Aaron. I think it's a genius move that they actually early on opened the JVM up and showed how to write bytecode. These other languages, a lot of them wouldn't have existed without the JVM doing that, because it gave them a really quick platform to build languages very quickly. You had Clojure and Scala, and earlier on JRuby and Jython. I think I remember Don was working on Jython very early on to do some scriptable code for some of the engines we were writing. So without them actually exposing what the bytecode of the virtual machine was and the way to write your own, a lot of languages would have to bootstrap themselves completely from scratch. And they still use the Java libraries too. You might be using Clojure, but you might be using Clojure with a bunch of Java libraries to interface with other systems. So really great.
We have two questions from the audience, so let's see if we can get to them. The first is Java helping Chariot in any way related to artificial intelligence or data science projects?
Well, I know we've done, I guess, more maybe data science than artificial intelligence. I don't know how you classify some of these projects. We've done a lot in Hadoop and Spark and, some of these tools. Has Java helped? I don't know. Those tools exist. We use them. I don't know that we write all our little bits of processing logic in Java. Some of them are in Python, some of them are in Java. I think it's great to have Java and these Java tools available. There are other languages and platforms you can do these things in. So I guess I don't really know how to answer that. We have used it, but certainly not exclusively.
Yeah, I think it's a mix. I think it's definitely a mix. I know that and I'm getting some information. We got some people that do, a lot of Apache tools and things like Flink. And so there are some APIs. There's isn't Parquet as a format, something that has a Java API for it? Maybe, I don't forget, but there's probably a fair number of tools that we end up deploying, but I don't directly use them. So I'm not 100% sure.
All right, and then this is a little longer from Gene. He asked, I have the perception that Java has become fragmented since Java 8 for commercialization reasons. It seems more complicated with all the options available to build an infrastructure. Oracle is driving SDK, JVM standards. Eclipse is driving J2EE standards. There are also open source JDKs. I'm having difficulty wading through all of these options. Am I overcomplicating things, or do you also feel the same way?
So Sun was a very good shepherd of Java for many years, right? And, you could reliably go to the, Sun website and get the Sun JDK, and that was that, right? In the grand scheme of things, I think it has been a positive to see the open source JDKs. I don't know that at the end of the day, Sun would have cared as much about Linux and Mac as some of the community members did. I don't know that the community would have cared so much about certain other platforms, you know, AIX or you know, whatever, Spark, as some of the companies did. So, you know, having an open source forum where everyone can come together and, you know, scratch their itches and, you know, build this platform out in all these different directions is good. But it, you know, yes, it does bring some fragmentation where then, you know, the open source website isn't as streamlined and easy to use as the old, you know, check a box and download a JDK kind of process. And Oracle has changed their licensing terms to be a little more commercial and stuff. So, you know, you get the good and the bad, right? I think, you know, pulling those developments into open source and then allowing someone to commercialize them is better than not having those improvements at all. But it does mean you have to wade through a little more. So, you know, on the whole, Java's still moving forward, and that's the important thing, I think.
And that seems like a really good place to end, because folks, that's 45 minutes that just went by like that. So Ken, I'm going to throw it over to you. Brian, it's nice to see you.
Hey, Brian. Yeah, so let's just take a quick couple minute break. I'm going to get some water here myself, and let me put up the screen. And yeah, we'll start up again in about 2 minutes. All right, 2 or 3 minutes.